All right, so here's a short little review on the, in preparation for your quiz tomorrow, mid-chapter review. So let's take a question where you might be asked to graph based on a sentence or some information. So let's say in this case that we say Amanda makes $10 an hour babysitting. And you're asked to graph, create a graph that represents that situation. You know, how much does she make over time or something like that. So you might start by making a table of values where your independent variable, the time, in this case, goes on the left side, and your dependent variable, the money that she earns, goes on the right side. From there, you'll build a set of axes, horizontal for time and vertical for earnings. Notice that your independent variable goes on the horizontal axis, and your dependent variable goes on the vertical axis. So on time, we're showing 1, 2, 3, 4, 5 hours. On the earnings, I went up by $10 chunks, but I only labeled every second one, so 20, 40, 60, etc. We use the coordinates 0 and 0 to draw points, 1 and 10, 2 and 20, 3 and 30, and we can draw a line through those points. Notice that it's a straight line, and I could continue. I could extend the line a little further with the dotted line if I wanted, beyond the points that I know. If you're asked to find how much Amanda makes if she babysits for an hour and a half, those are between the data points that you know. That's called interpolating. And if you go to 1.5 hours and you go up, that little green line there, you'll see that she makes $15 for that. You could be asked to extrapolate instead and find out how long Amanda worked if she made $50. So you'd start at $50 on the earnings axis, over to the red line and down, and you'd see that she must have worked for about 5 hours. Back that up if you need to see it again. Now, solving linear equations came from section 5.4. When we solve linear equations with inverse operations, we solve by using BEDMAS and going backwards. Everything is kind of the inverse. So in a case like this, we want to get rid of anything that's added or subtracted to the term with the x in it. So I'm going to get rid of that negative 11, move it to the other side by adding 11 to both sides. That gives me negative 3x is equal to 18. Then I want to get rid of the 3 that's attached to the x. And it's negative 3 times x, so I'm going to do the opposite of that and divide, or the inverse I should say, and divide both sides by negative 3. That leaves me with x is equal to negative 6. In example 2, we've got 2/3 x plus 9 is equal to 4. Similar to the question above in style, instead of a negative 3, we've got this 2/3. So I'm going to start by moving the 9 over to the other side. Inverse of addition is subtraction. So I get 2/3 x is equal to 4 minus 9, or negative 5. And then I want to get rid of the 2/3. But instead of dividing by the fraction, we're going to multiply by its reciprocal. So 2/3 times 3 over 2 gives me 6 over 6, which cancels out. And negative 5 times 3 over 2 becomes negative 15 over 2. Notice it's not negative 15 over 10, or negative 10. Now example 3, we've got w plus 3 over 4 is equal to 2. That line there under the w plus 3, that division line, is like a grouping symbol. It's like a set of brackets. And just like we've been doing the inverse of the other operations, instead of doing what's inside the brackets, we do what's outside the brackets first. So I want to get rid of that divided by 4, and I'll do that by multiplying both sides by 4. That leaves me with w plus 3 is equal to 8. Now we can move the 3 over by subtracting 3 on both sides, and we get w is equal to 5. Now in this fourth example, you'll see that the variable is in the denominator. But we still do the same kind of things. We want to get rid of whatever's added or subtracted to the term with the x in it. So I'm going to subtract 1 from both sides. But because we're working with a fraction on the right side, we've got 2/5, and we're going 2/5 minus 1. Notice that I rewrite the minus 1 as 5/5. So I have a common denominator right away to work with. That leaves me with negative 3 over x is equal to negative 3 over 5. And the 5 stays the same because it's a common denominator. When we add or subtract, the denominator doesn't change. Now, Note that these two fractions are equal. Negative 3 over x is equal to negative 3 over 5. And if the denominators or the numerators, I should say, are also equal, then it must be true that the denominators are equal. So x must be 5. Now, this isn't a common situation, but it will pop up. If the numerators aren't the same, we could solve for x by multiplying both sides by the denominators. Essentially, it's called cross multiplication. I multiply the right side by x, the left side by 5. I get negative 3 times 5, or negative 15, is equal to negative 3 times x, or negative 3x. Divide both sides by negative 3, and x equals 5. Notice it's a positive 5 because the two negatives canceled out. That's it for now. We'll see you tomorrow.